Hey y'all, today we are doing a lesson about mean absolute deviation, which sometimes you see written as MAD, MAD. So this is a little mini lesson about that. So mean absolute deviation is a measure of variability. Or how spread out the data is. So the greater the MAD, the mean absolute deviation, the greater the variability of the data. So our directions say find the MAD, the mean absolute deviation of each data set. So for number 1, we've got the number of words in book titles. So our first step is to find the mean of the data. That means I need to add up all of these numbers here and divide by the total number of terms. So 1 plus 2 is 3, plus 2 is 5, plus 3 is 8, plus 2 is 10, plus 3 is 13, plus 2 is 15, plus 3 is 18, plus 6 is 24. And you could use a calculator to do that if you want, but I've got 24. Now I've got to divide that by the total number of terms. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 terms. So I'm dividing 24 by 9, and I'm going to go to my calculator and put that into my calculator. 24 divided by 9 gives me that decimal 2.6 repeating. So I'm just going to use 2.6. Okay? So we have 2.6. Now, that's the mean, and that's really, really important. Okay? So now what I'm going to do is I'm going to take every single term and subtract the mean from it. So what that's going to look like, our very first term was 1. So we're going to have 1 minus 2.6. And then we're going to have, let's just go ahead and do that. 1 minus 2.6 is going to be negative 1.6. Okay, the next term we had was 2. So 2 minus 2.6 equals negative 0.6. The next term we had was 2. So 2 minus 2.6 again is negative 0.6. The next term we have was 3. So 3 minus 2.6 is going to be 0.4. After that we had 2 again. So 2 minus 2.6 equals negative 0.6. After that 2, we had another 3. So 3 minus 2.6 equals 0.4. Then we had another 2. So 2 minus 2.6 equals negative 0.6. Then we have a 3. 3 minus 2.6 equals 0.4. And we've got one more. I'm going to see if I can use some teacher magic and move this up. Okay, the last one was 6. So 6 minus 2.6 is 3.4. Okay, now I'm going to take the absolute value of all of these new terms. That means I'm going to make every single one of them positive, even if they are not initially positive. Okay, so I'm going to use 1.6, 0.6, 0.6, 0.4, 0.6, 0.4, 0.6, 0.4, and 3.4. And I'm going to add all of those terms up together, okay? So remember, I just made them all positive. I took the absolute value of all of them. They're all positive. And I'm adding them up together. So I'm using my calculator. I've got 1.6 plus 0.6 plus 0.6 plus 0.4 plus 0.6 plus 0.4 plus 0.6 plus 0.4 plus 3.4. And when I add all that up, I get 8.6. So 8.6. And I'm going to divide that by the total number of terms we have, which remember is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm dividing that by 9. Okay, so 8.6 divided by 9 is going to be a very, very small number. It's going to be 0.95. And that 5 is repeating. So 0.95 repeating is my mean absolute deviation. It's a really small number. And so what that means is that the data is actually pretty close together. It's not really spread out. Okay, so let's move on to number 2. So in number 2, we have the age at first job. So first step is to find the mean. So I'm going to add up all of these numbers. 17, plus 14, plus 17, plus 16, plus 17, plus 21, plus 17, plus 14, plus 12, and that's it, okay? So I'm using my calculator for that. So I'm going to go over here. So we have 17, if I can click the 7, plus 14, plus another 17, plus 16, plus another 17, plus 21, plus 17, plus 14, plus 12. So we get 145. Now, we need to take that 145 and we need to divide it by the total number of terms we have. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm dividing by 9. And I get 16.1. So we know that we get 145 and we divide by 9 and we get 16.1. That 1 is repeating, but we're not going to just bother with that right now. Okay? So now we need to find how far away each term is from that mean. So we're going to subtract everything from the mean. So let's start with 17. So 17 minus 16.1. And 17 minus 16.1 is going to be 0.9. Okay? Next, I'm going to do 14 minus 16.1. So 14 minus 16.1 is going to be negative 2.1. Then I have 17 again. So 17 minus 16.1 is 0.9. Then I have 16. So 16 minus 16.1 is going to be negative 0.1. After that, I have 17 again. So 17 minus 16.1 equals 0.9. Then I have 21. 21 minus 16.1 is 4.9. Then I have a 17 again, so 17 minus 16.1, 0.9. Then I have a 14 minus 16.1, and 14 minus 16.1 is negative 2.1. And let's see, can I use a little teacher magic to move this up just a little bit? Oops, give me a little bit more room. How about like that? Okay. Lastly, I have 12. So 12 minus 16.1 is negative 4.1. Okay. Now our next step is to take all of these terms here and make them positive. So I'm taking the absolute value of all of them. So I'm just going to rewrite them all positive. So we start with 0.9, then 2.1, 0.9, 0.1, 0.9, 4.9, 0.9, 2.1, and lastly 4.1. So I just rewrote all of those same numbers positive because I'm taking the absolute value of all of them. And now I'm going to add up all of these terms and divide by the total number of terms. So in my calculator, I've got 0.9 plus 2.1, 0.9 plus 2.1 plus, what do I have next? 0.9 plus 0.1, 0.9 plus 0.1 plus 0.9 plus 4.9, 0.9 plus 4.9 plus, what else? 0.9 plus 2.1. Plus, and I think the last one is 4.1. And I get 16.9, okay? So we add those all up together and we get 16.9. Now we divide by the number of terms that we have. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm gonna put that into my calculator. So we have 16.9 divided by 9, and we get 1.87 repeating. So I'm just going to write that as 1.9. I'm just rounding it up just so I have just one decimal place. Actually, no, I wrote 2 decimal places last time. So let's leave that with 2 decimal places. 1.87 repeating. Is that what we said? Yes, 1.8 with the 7 repeating. So that right there is our mean absolute deviation. I do want to mention that on your test, I have worked out the problem about mean absolute deviation, and you will not be getting all of these decimals. So that is the good news that you can look forward to on your test. Okay, let's look at the next one. We've got games per World Series. So we're going to add up all of these numbers. We have 5 plus 6 plus 4 plus 5 plus 7 plus 5 plus 4 plus 5 plus 7 plus 6 plus 4. So I'm going to use my calculator that I have over here to the side, so I'm not going back and forth again. So 5 plus 6 plus 4 plus 5 plus 7 plus 5 plus 4 plus 5 plus 7 plus 6 plus 4. And we get 58. Okay, now we need to divide that by the number of terms that we have. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. So we're dividing 58 by 11. And when we put that into our calculator, 58 divided by 11 is 5.27 repeating. So I'm just going to do 5.3. Okay, just to keep it easy because this is my mean, right? So now I have to take every term and subtract the mean from it. So we're going to start with 5. So we have 5 minus 5.3, and we get negative 0.3. Next we have 6 minus 5.3, and we get positive 0.7. Next we have 4 minus 5.3, and we get negative 1.3. Next we have 5. So 5 minus 5.3 is going to be negative 0.3. After that we have 7. 7 minus 5.3 is going to be, I think, 1.7. Yep, 1.7. Then I have another 5. So 5 minus 5.3 is negative 0.3. Then I have a 4. 4 minus 5.3 is negative 1.3. Then we have a 5. 5 minus 5.3 is negative 0.3. Then I have a 7. 7 minus 5.3 equals 1.7. And I've got to continue. There's no way I can keep going. So after that, I have a 6. 6 minus 5.3 is going to be 0.7. And lastly, I have a 4. 4 minus 5.3 is negative 1.3. Okay. So now what I'm going to do is I'm going to take all of these new numbers and I'm going to make them positive. So I'm going to rewrite them all so that they are positive. So we've got 0.3, 0.7, 1.3, 0.3, 1.7, 0.3, 1.3, 0.3, 1.7, 0.7, and 1.3. Okay, so that should be all 11 of them. 2, 3, 4, 5, 7, 8, 9, 10, 11. It is. So I now want to add up all of these numbers. So let's do that. So I'm using my calculator that I have over here to the side. So I have 0.3 plus 0.7 plus 1.3 plus 0.3 plus 1.7 plus 0.3 plus 1.3 plus 0.3 plus 1.7 plus 0.7 plus 1.3. And I get 9.9. So I get 9.9, and I divide that now by the number of terms we have, which is 11. So 9.9 divided by 11 is going to be 0.9. So 0.9 is our mean absolute deviation. So the data is pretty close together. It's not very spread out. Okay, last one that we are going to look at today is number 4, quiz scores. So we are first going to add up all of these numbers. So 41, plus 46, plus 37, plus 47, plus 54, plus 40, plus 35, plus 44, plus 53, and we're going to figure out what that equals. So just so I'm not going back and forth again, I'm just putting this into my calculator over here to the side. So 41 plus 46 plus 37 plus 47 plus 54 plus 46 plus 35 plus 44 plus 53. All of that equals 403. So 403. And I want to divide that by the number of terms that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. So I'm dividing that by 9. So 403 divided by 9 is 44.7 repeating. So I'm just going to write that as 44.7. Okay? So now that I've got my mean, I'm going to subtract every term from the mean. Or I'm going to subtract the mean from every term. Sorry. So let's start. I'm just going to rewrite them all here. 41, 46, 37, 47, 54, 46, 35, and 44, and then 53. And that should be all 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is. Okay, so I'm subtracting the mean from every single one of those terms. So 41 minus 44.7. Well, 41 minus 44.7 is going to be negative 3.7. Okay, now 46 minus 44.7. 46 minus 44.7 is 1.3. So now 37 minus 44.7 is negative 7.7. 47 minus 44.7 is 2.3. 54 minus 44.7 is going to be 9.3. 46 minus 44.7 is 1.3. 35 minus 44.7 is negative 9.7. 44 minus 44.7 is negative 0.7. And 53 minus 44.7 is going to be 8.3. Okay, so now that I've done that, I'm going to take all of these new terms right here, and I'm going to make them positive. So I'm taking the absolute value of each one, but I'm just going to rewrite them so that they're all positive. So we have 3.7, 1.3, 7.7, 2.3, 9.3, 1.3, 9.7, 0.7, and 8.3. And now I'm going to add up all of those terms. Okay, so I'm adding them all up. I'm using my calculator. So I have 3.7 plus 1.3 plus 7.7 plus 2.3 plus 9.3 plus 1.3 plus 9.7 plus 0.7 plus 8.3. When I add that all up, I get 44.3. So 44.3. Now I need to divide that by the total number of terms that we have, and it's the same number of terms we had before. It's 9. So 44.3 divided by 9 gives us 4.92, and that 2 repeats. So 4.92, repeating, is our mean absolute deviation. So now I want to ask you, of our data sets that we have found the mean absolute deviation for, which one is the most spread out? In other words, which one has the greatest variability? And if you said the last one, number 4, you are correct. Oops, let's see if I can fix that. So this data set has the greatest variability because the mean absolute deviation is the greatest. Okay, so you will need to be able to tell between two data sets which one has more variability. So that's why I point that out. That has the biggest mean absolute deviation, so it has the greatest variability. That is the end of our little mini lesson on mean absolute deviation. Have a great day.